Hello students, this is Surya Nair and today we are going to start with a very beautiful chapter, that is probability. Now when I say probability, it comes with the word probably, maybe or maybe not situations, wherein we are not sure about the situation. For an example, it may rain today or it may not rain today. India may win the match, India may lose the match. So maybe or maybe not situations. Probability was not suddenly discovered by any mathematician. It actually got discovered in a gaming session called as gambling, wherein the players used to guess which number is going to come. And from there, this type of game got invented, discovered, and then our mathematician used many terms, they did many research, and then they came up with a beautiful chapter, probability. It deals with experiments basically, because you must have done science practicals in your science lab wherein we do experiments and we wait for the result. So similarly, probability also deals with experiments and it deals with random experiment. Random experiment means an experiment wherein you know all the results in advance but cannot be predicted with certainty. Now when I say that you know all the results in advance but cannot be predicted with certainty, what I exactly mean is, just take an example of tossing a coin. A normal example. If I toss a coin, come on, I am tossing it. What did I get? Head, tail. Now I know the possible outcomes. I know the results in advance. Either it can be a head or it can be a tail. But I don't know with certainty that it is a head or it is a tail. I know the results. It can be a head or a tail. But I cannot predict with certainty that it is a head or it is a tail. That means this experiment says that its results are unknown. But guesses can be made, predictions can be made. Let's take one more example. You all know a die. When we play snake and ladder, we use a die. When we roll it, we know 1, 2, 3, 4, 5, 6. These numbers can come. That means we know the results in advance. But we cannot predict with certainty that definitely 3 will come. Definitely 5 will come. Yes, you can make the guesses, but then you can't predict with certainty. So these are called as random experiments. The next term over here is outcome. When I roll a die and 1 comes, that is the result of the experiment. So that result of the experiment is called as outcome. If I roll a die and 5 comes on the upper face of the die, that 5 becomes the outcome. If I toss a coin and head comes in the upper face, so that head becomes the outcome. So result of the experiment is nothing but the outcome. Now, the king of the chapter, sample space. If you know sample space, you will be able to do this chapter beautifully. Sample space is a set of all possible outcomes. Now, when I say it is a set of all possible outcomes, you will be doing different experiments over here and you have to write down the possible outcomes of those experiments. So, we are taking the example of die, coin. So, similar example we are going to take now and we are just going to solve what sample space will be. Let's take again the example of a die because it is very easy to understand. Now, when I roll a die, I know 1, 2, 3, 4, 5, 6. These are the numbers which are going to come. These are the outcomes. So, sample space says write down all the possible outcomes in me. So, sample space is a set of all possible outcomes. And sample space is a set. Therefore, the elements of sample space is written inside curly brackets. And it is represented by a capital letter S or a symbol called as omega. But usually, most of the time we consider capital letter S. So as we have taken the example of rolling of a die, we know 1, 2, 3, 4, 5, 6 are the possible outcomes. So I'll write sample space S is equal to Since it is a set, you will write it inside curly bracket and you will write down the outcomes. 1, 2, 3, 4, 5, 6. You will write down all the possible outcomes. You don't want the final result. That will come later. So these are the possible outcomes which will come in sample space. After writing down sample space, you will write down n of s. That is the number of elements in S. So n of s is written like this. N of s. You will count the elements. 1, 2, 3, 4, 5, 6. How many elements are there? 6. So n of s will be 6. So this is the way how you will write sample space. I am taking one more easy example. A coin tossed. We know the possible outcomes, that is H and T. Because when I toss a coin, it can be head or tail. And in this chapter, we can denote head by H and tail by T. So how will we write? S is equal to curly bracket H comma T. And N of S will be 2. So this is the way how we are going to represent our sample space. And in this chapter, we are going to do many sample space, and that is the core of this chapter. In the beginning, we will write sample space, then we will solve the sum as per the event. Now, what event is that we will learn after we learn sample space. Now, I am taking one more example.